Right, so imagine this. You and your friend go buy two balloons from a shop, and what you do is you rub these balloons with your hair, and after that you try to bring them together. So what do you think will happen? You can think about it while I'll begin. So before I begin with the topic, I'll briefly introduce myself. So my name is Jasnoor and I'm pursuing BTech in Electrical Engineering at IIT Mandi, and I'm a fourth year student. So what today we'll be covering what Coulomb's law is, and we'll also look at some of the formulas used in Coulomb's laws, and we'll take a look at two examples which are important from your examination point of view. So let's get started. So I hope that you guys would be familiar with what charge is, right? And I would also be discussing two important properties of charge before I begin with Coulomb's law. So that is like charges repel and unlike charges attract each other. And this should answer the balloon question too. So when you rub the balloon with your hair, the electrons get transferred from hair to the balloon, and that makes it negatively charged. So what happens when you bring two negatively charged bodies to each other? They're like charges and they start repelling each other. So we looked at that they're repelling or they're attracting each other, which means that there should be some force acting between them, right? So how do we measure this force, or in what direction would it act? How would we know that? And this is where our Coulomb's law comes in. So first of all, remember that Coulomb's law is basically only for point charges, right? So let's say we have a point charge Q1, we have another point charge Q2, and we have a distance of d between them. Got it? So Coulomb's law says that the force acting between the two charges, let's call it as 1 and charge 2, right? So force would be directly proportional to the product of their charges. So this is directly proportional to Q1, Q2. And the force would be inversely proportional to the square of distance separating them. So force is inversely proportional to the square of distance separating them, got it? 1 upon d square. And we can combine these two to form that force is directly proportional to Q1, Q2 upon d square. So what do we do to remove this proportionality sign? We add a constant here. So force is equal to K Q1 Q2 upon d square. Got it? And let's see what this K is. So here K is basically 1 upon 4 pi epsilon naught. So what is epsilon naught? Epsilon naught is the permittivity of free space or vacuum. So the value of epsilon naught is 8.85 into 10 to the power minus 12 farad per meter. So this is farad per meter. Farad is the unit of capacitance. We will study more about capacitors in electrical circuits. And so when we put this value in this equation, we get K to be nearly equal to 9 into 10 to the power 9 Newton meter square upon Coulomb square. So this is the value of K. We can just write our force is K Q1 Q2 upon d square. So force is a vector quantity, you might know that. So which means that there should be a direction for it. So how do we find that direction? Suppose let's say there's a charge here, there's a charge here, Q1 Q2, this is D. So what would be the direction of force on first charge due to this charge? So the direction is along the line joining them. So this is the line joining them, and the direction would be direction of the force applied on these two would be along the line joining them. So this is force on 1 due to 2. This is force on 2 due to 1. So their magnitudes will be equal, right? F21. This is given. I mean, this is pretty obvious. And next, so let's say that Q1 and Q2 are like charges. Suppose both are positive or both are negative. So the force would be acting outwards because they would be repelling each other. So they're like charges, the force would be acting outwards, right? And if they're unlike charges, let's say Q1 is positive and Q2 is negative. So you can also see that the product would be negative, and that means that if a negative force is acting on outside, that means a positive force is acting towards inside. So if they have different sign, they would getting attracted towards each other. And that's, I guess that also clears that like charges repel and unlike charges attract each other. Alright. Let's move on to a pretty basic example. Let's say you have a charge of 2 coulombs and another charge of 3 coulombs. You have a distance of 2 meters between them. Let's make it minus 3 coulombs. So find me the force acting on particle 1, find me its magnitude, and find me its direction. Right. So let's begin with the answer. So what would be the magnitude? Magnitude would be K dot Q1 is 2, Q2 is minus 3 upon, this is the modulus sign, 2 square, distance between them 2 square, right? So the magnitude would be 3 into 9 into 6 into 9 into 10 to the power 9 upon 6 into 9 into 10 to the power 9 and 4. That is 13.5 into 10 to the power 9 Newton. So this is the magnitude of it, and what would be the direction? The direction would be towards each other because they are unlike charges, they would be attracting each other. And this was a pretty basic question. Let's move on to the next example. So next example is that suppose you are given an equilateral triangle, 60 degree. This is A, this is A, say this is, and there are 3 point charges kept at the 3 corners, Q, 2Q, and 3Q. So find me the magnitude of the force acting on this charge. So I'll start solving. You can pause it and solve it. So we have V. So what would be the direction of force acting on Q because the charge 2Q? It would be along this direction because they are of the same side. So they would be repelling. This is, I'll say it F1. And what would be due to 3Q? It would be along this direction. This is F2. Got it. So what would be the angle between these two forces? And you can say that this angle would be 60 degrees. So this is 60 degrees. So you know the values of F1, which is K into 2Q into Q upon A square. So 2K Q square upon A square. You know the magnitude of F2. And the magnitude of F2, K into Q into 3Q upon A square. So this is 3K Q square upon A square. Got it? So we know the two vectors, and we know their angle, which is 60 degrees. So You just need to do a vector addition for them. I hope you all know how to do that. F would be root of f1 squared plus f2 squared plus 2 f1 f2 cos theta. Theta is the angle between the two forces, which is 60 degrees, so cos theta would be half, right? And we can write it as f1 square would be 4 k square q to the power 4 upon a to the power 4 plus f2 square would be 9 k square q to the power 4 upon a to the power 4 plus 2 into f1 f2 would be 6 k square q to the power 4 upon a to the power 4 dot cos 60 degrees would be 1 by 2. This 2 gets cancelled here. So we can take k square q to the power 4 upon a to the power 4 as common and bring it out of the root. So that would be k q square upon a square root of 4 plus 9 plus 6. What is this? This is 13 plus 6, 19 k q square upon a square into root 90. So that would be the magnitude of the force acting on Q. And so in this lecture we looked at what Coulomb's law is, how it governs the forces of attraction and repulsion between two charged bodies, and we also looked at some examples. And in one of the examples we looked of a three charge system in which there were two forces acting on a single charge, and that should give you a pretty good idea what Coulomb's law is and how it works. So Coulomb's law is also not just a theoretical concept, right? Like we know that suppose for any atom we have a nuclei, we have electrons revolving it. So the revolution of electrons, the forces of interaction between the nuclei and the electron is all governed by the Coulomb's law because they are charge carrying particles. And so that's it for today's lecture. And yeah, one more thing before I end it. I want you guys to find out how a lightning strike works, because that's a really interesting topic, and it's like also part of it's a phenomenon of electrostatics. So I think Wikipedia is a good source, and there are a few very good YouTube videos on how a lightning strike works. So yeah, we'll discuss about it in the next lecture. Meanwhile, you guys can explore it. See ya.